glorious years, and the initiative has been taken to organize a series of Golden Jubilee lectures. And today is the fourth Golden Jubilee lecture. A very good morning to you all present here. Respected dignitaries, Chief Guest, Professor Leela Kantanab, Vice Chancellor, Jubilee University, Special Chief Guest, Dr. Rajkumar Ranjan Singh, Honorable Union Minister of State for External Affairs and Education, Guest of Honor, Professor Jiten Hazarika, Registrar, Jubilee University, Guest of Honor, Dr. Manoj Phukon, Senior Scientist and Group Leader, Geosciences and Technology Division, CSIR, NEIST, Jorhat, Guest Speaker, Dr. Binoy Kumar Soikia, Senior Scientist and Assistant Professor, Academy of Scientific and Innovative Research, and Head of the Department, Coal and Energy Division, CSIR, NEIST, Jorhat, Dr. Diganto Bhuiya, Head of the Department, Applied Geology, Jubilee University, and the faculty members, officers of Jubilee University, research scholars, students, media friends, and ladies and gentlemen present here. It's my pleasure to welcome you all on the behalf of Department of Applied Geology, Jubilee University Research Scholar Association, and the entire Jubilee University fraternity to the fourth Golden Jubilee Lecture on Revisiting Coal Science and Technology for Sustainable Development, organized by Department of Applied Geology, Jubilee University, and the Jubilee University Research Scholar Association. May I now request our Chief Guest, Professor Leela Kantanab, to kindly take the seat on the dais. I request our research scholar to escort him to the dais. Now I request our Dr. Gitartha Datto to felicitate him. I request Dr. Gitartha Datto to felicitate him. Thank you, Gitartha. May I now invite our special chief guest, Dr. Rajkumar Ranjan Singh sir, to take the seat on the dais. I request our research scholar to escort him to the dais. I request Dr. Himanto Borgohain to felicitate him. Thank you, Himanto. May I now request our guest of honor, Professor Jiten Hazarika sir, to take the seat on the dais. I request Bhargav Bhattacharya to felicitate him. Thank you, Bhargav. May I now again request our guest of honor, Dr. Manoj Phukon sir, to kindly take the seat on the dais. I request Hirab Jyoti Dehinia to felicitate him. Thank you, Hirab. May I now invite our guest speaker, Dr. Binoy Kumar Soikia sir, to kindly take the seat on the dais. I request Mr. Pranjit Polita to felicitate him. Thank you, Pranjit. May I now request our head of the department, Applied Geology, to take the seat on the dais. I request Ms. Malvika Bora to felicitate sir. Thank you, Malvika. Thank you, dignitaries and all the members present here for gracing the program with your esteemed presence. I request our students of Department of Applied Geology to get ready for the university anthem. Thank you all. Chief guest, Professor Leelakanta Nath, sir, to deliver welcome address and formally inaugurate the program.
Respected guest, Dr. Rajkumar Ranjan Singh, Minister of State for External Affairs and Education, Government of India, Dr. Manoj Phukon, Principal Scientist and Group Leader, Geoscience and Technology Division, CSRI NES, Jorhat, Professor Jiten Hazarika, Registrar, Jubilee University, Guest of Honor, Guest speaker, Dr. Binoy Kumar Saikia, recipient of the prestigious Santi Swarup Bhatnagar Award 2021 in the Earth, Atmosphere, Ocean and Planetary category. Dr. Diganta Bhuya, Head of the Department of the Applied Geology. Faculty members from different departments and Center for Studies of Jubilee University. Invited guests, representative from All India Radio, Doordarshan, research scholars, and student friends. I am very much pleased to be a part of this occasion, and it is my great pleasure to inform you that the Department of Applied Geology is celebrating its glorious 50 years, and on this occasion, it is organizing this Golden Jubilee lecture series, and this is the 4th lecture in that series today. It is an honor for the Jubilee University that Dr. Rajkumar Ranjan Singh has graced this event. Dr. Singh, your presence is a valuable addition which will surely inspire all of us. Dr. Manoj Fukan is an alumni of Jubilee University from the Department of Applied Geology. Dr. Binoy Kumar Saikia, the great son of this soil, who has made us all proud, needs no introductions. This university is honored to have you among us as guest speaker today. I sincerely hope this expertise and experience in the field of coal chemistry is an excellent addition to the program, and your lecture on revisiting coal science and technology for sustainable development will benefit the research scholars and students, especially of this university. I welcome you all to this event and hence declare this 4th Golden Jubilee lecture being inaugurated. I also extend my sincere thanks to the convener of this event for organizing such an important lecture in this university. With this, I thank you all very much. Thank you.
Thank you, sir. May I now request our special chief guest, Dr. Rajkumar Ranjan Singh, sir, to address the gathering.
Good morning, everybody. Honorable Vice Chancellor, Professor L.K. Nathji, and Professor Jiten Saikia, Guest of Honor, Registrar of the University, Dr. Binoy Kumar Saikia, Guest Speaker, Bhatnagar Awardee, and senior scientists from CSIR and NICS, Dr. Manoj Fukan, Guest of Honor, and Dr. Bhuyan, heads of the Applied Geology, and young research scholars and students, and the community of the Jubilee University. I am very feel happy and also getting the good chance to be here in this momentous the 4th round of Jubilee lecture. I am quite lucky, and most lucky person is me. When I visit to Honorable Vice Chancellor's room, he just asked me to join this the Golden Jubilee lecture, and I was so happy to get the knowledge of this. Of course, at the moment I belong to the community of politics. but basically I'm not a politician. I started all my life with the academic community, and also one time a research scholar under Guwahati University, and have a lots of friends all throughout the Assam. Some of my friends, I'm not able to link with them till today. So this is my tragedy. I could not find out their address and others. Anyway, I have a special inspire and the feeling of seeing the geology department long back in 1984, when I visited first time here in the Jubilee University for some purpose. That time, one of my friends, of course, he is junior to me. He was a professor, retired from Guwahati University, Dr. I could not remember his name also. Not but the geology department. I cannot remember. His home is somewhere in the 7 Mile site. And so he was first, perhaps he was working here under the Applied Geology department. And then he changed to Guwahati University. And during my research career, I have a close attachment with Dhiren Das. I remember Professor Dhiren Das. And he told about the Department of Applied Geology under Jubilee University. This is one of the most excellent and most appropriate department who imparting the young students to the applied geology, and also there is a facility for sponsored by the Oil India, and that's a good combination and providing a good the future generation of the geologists from this university. And again, I was also very happy when I joined to politics, and I was in the Standing Committee of Science and Technology and Communication and Forest and Environment quite a long before joining to the Union Ministers group. That time, I know CSIR, they are the only institution in the country. They invented, they innovated, they produce a lot of Atmanirbhar Bharat in all the fields of the science and technology and contribution to the society. Today, I'm lucky to be here with the special occasion of this fourth lecture, and Dr. Vinod Kumar Saikia. He belongs to that CSIR and NITS. And even in Assam and Northeast India, CSIR has done a lot of things. We have a small field lab in Imphal. Even then, under the guidance of this CSIR Zorahat, they have done a lot of things. During the COVID, the CSIR produced a lot, right from the hand sanitizer to different kind of production they have done it. So I have nothing to say, but Northeast India is one of the most specific and significant region of the country. And our Honorable Prime Minister, Shri Narendra Modi ji, has a special interest, and also he treats it as aspirational region of the country. He always keep in his mind that Northeast India, though we said that NE, he very frequently advises us, this is NE means Northeast India. He said that is the new engine for the growth of the country. Therefore, the University of Dibrugarh and also the applied the geology department has a main role to activate the whole region, and the new generation should be imparted with the new technology and a new knowledge system. And also I'm very happy to learn today that study of Brahmaputra. These days, the education system has changed. We should not confine in a conformamental, traditional discipline, physics, chemistry, not like that in this present trend. We have to, there should be multidisciplinary system of approach of studies. And I was also very happy when I just joined in the Council of Ministers, the Indira Gandhi National Open University asked me to launch a new subject. And when I asked what kind of subject, they said that science of sustainable, and that is linked with the United Nations Sustainable Development Goals. That 15 goals are there. That has to be reoriented in all our the university studies, including the research. So today, the topic where Dr. Binoy Kumar Saikya is delivering is one of the most important topics. We are talking about the global climate change. We are talking about the zero carbon emissions. Our Prime Minister has already assured to reduce the zero carbon network by 2033 or something like that. I cannot remember exactly the time target. So under such circumstances, with the commitment and the assurance of our Prime Minister, our academic institution has the main role to achieve the assurance given by our Prime Minister, and we are in the forefront to reduce the carbon emissions. So in this time, the revisit of coal technology is very, very important one and pertinent one. And in our student time, we just heard about the coal washing. The dust material and smoke material has to be removed from the raw coal. But now, Binoyji will deliver in a different form and new technology so that by this revisit with the new technology, with the idea of sustainability, that carbon portion should be reduced from coal. On the other hand, our coal deposit is very limited. We are trying to import from Russia, and now we are negotiating with the Australian coal company so that our coal deficit should be recouped to achieve our sustainability in our energy. So with these few words, I hope Dr. Binoy Kumar Saikya will deliver the issues of the sustainability and revisit of coal technology so that it will link with the zero carbon network. With these few words, again, thanks to the organization for giving such kind of opportunity, and also getting the chance of meeting all the young scholars and students and communities of the university. It's quite lucky for me. So with these few words, thank you. Jai Hind.
We are very much honored to have you with us today, sir. Thank you so much for addressing the gathering. Sorry. May I now introduce our guest of speaker. We are very much privileged to have with us our today's guest speaker, Dr. Binoy Kumar Saikya, who is the recipient of prestigious Santi Swarab Bhatnagar Award in 2021 in the Art, Atmosphere, Ocean and Planetary Sciences category by the Council of Scientific and Industrial Research, Government of India. May I now request Professor Kalpana Deka Kolita Madam to brief introduction of Dr. Binoy Kumar Saikya.
Swagatam আৰু হিয়া ভৰা অভিনন্দন ডক্টৰ বিনয় কুমাৰ শইকীয়াজী। আমি ডিব্ৰুগড় বিশ্ববিদ্যালয়ৰ সমূহ সদস্যবৃন্দ অতি আনন্দিত আৰু কৃতজ্ঞ আপোনাক আমাৰ বিশ্ববিদ্যালয়ৰ মজিয়াত পায়। আপোনাক পৰিচয় দিয়াৰ প্ৰয়োজন অকণমানো নাই। তথাপি আজিৰ সভাত উপস্থিত থকা আমাৰ বিশ্ববিদ্যালয়ৰ নৱপ্ৰজন্মৰ গৱেষক গৱেষিকা আৰু ছাত্ৰ ছাত্ৰীসকলক আপোনাৰ কৰ্মৰাজি আৰু সাফল্যৰ বিষয়ে দুআষাৰমান জনাবলৈ চেষ্টা কৰিছোঁ। তাৰ বাবে মই হে সন্মানিত আৰু আনন্দিত অনুভৱ কৰিছোঁ। ডক্টৰ শইকীয়াই গোলাঘাট জিলাৰ সৰুপথাৰত জন্মগ্ৰহণ কৰে। তেখেতৰ পিতৃ শ্ৰী শ্ৰীযুত বীৰেন্দ্ৰনাথ শইকীয়া, প্ৰাথমিক স্কুলৰ শিক্ষক, আৰু মাতৃৰ নাম শ্ৰীযুতা বকুলি শইকীয়া। মাতৃৰ কোলাত বহি থকা কণমানি শিশুটিয়ে আমাক সকলোকে গৌৰৱান্বিত কৰা আজিৰ সভাৰ আমন্ত্ৰিত অতিথি ডক্টৰ শইকীয়াদেৱ। তেখেতৰ শিক্ষা জীৱন আৰম্ভ হৈছিল সৰুপথাৰ প্ৰাথমিক বিদ্যালয়। 1993 চনত সৰুপথাৰৰ ডন বস্কো বিদ্যালয়ৰ পৰা উচ্চ মাধ্যমিক শিক্ষান্ত পৰীক্ষাত উত্তীৰ্ণ হয়। তাৰপিছত গোলাঘাটৰ দেৱৰাজ মহাবিদ্যালয়ৰ পৰা বিজ্ঞান শাখাত উচ্চতৰ মাধ্যমিক শিক্ষান্ত পৰীক্ষাত উত্তীৰ্ণ হৈ একেখন মহাবিদ্যালয়ৰ পৰাই 1998 চনত বিজ্ঞান শাখাত স্নাতক ডিগ্ৰী লাভ কৰে। দেৱৰাজ ৰয় মহাবিদ্যালয়ৰ মজিয়াৰ পৰা উচ্চ শিক্ষাৰ বাবে ডক্টৰ শইকীয়াদেৱে গুৱাহাটীৰ তেতিয়াৰ কটন কলেজ আৰু এতিয়াৰ কটন বিশ্ববিদ্যালয়ত ভৰ্তি হৈ 2001 চনত ৰসায়ন বিজ্ঞানত স্নাতকোত্তৰ উপাধি লাভ কৰে। তাৰ পিছত তেখেতে ডিব্ৰুগড় বিশ্ববিদ্যালয়ৰ আৰু নিষ্ট যোৰহাটত যুটীয়াভাৱে PhDৰ গৱেষক হিচাপে গৱেষণা আৰম্ভ কৰে আৰু 2008 চনত এই বিশ্ববিদ্যালয়ৰ পৰা ডক্টৰেট উপাধি গ্ৰহণ কৰে। শিক্ষা সমাপ্ত কৰি ডক্টৰ শইকীয়া 2005 চনৰ পৰা 2009 চনলৈ তেজপুৰ বিশ্ববিদ্যালয়ত সেৱা আগবঢ়ায়। 2009 চনৰ পৰা 2011 চনলৈ তেখেত ইণ্ডিয়ান অইল কৰ্পোৰেশ্যন লিমিটেডত কৰ্মৰত আছিল। Now I am moving on to his professional and research life. Dr. Binay Kumar Saikia is an Indian chemist, a senior scientist, HOD, Coal and Energy Division at CSIR Northeast Institute of Science and Technology, Jorhat, Assam. Dr. Saikia's contributions were primarily on alternative utilization of Indian coal and its value addition products from abundant low-grade coals. His works also include contribution on air quality evaluation, aerosol chemistry, and its mitigation approach. He developed a technology for the production of blue fluorescent carbon quantum dots from Indian coal, which is patented both in India and US. Dr. Saikia has made outstanding contributions on the formation of fluorescent carbon quantum dots, CQDS, from Indian coal. His indigenous patented CQD technology for diverse application falls under Atmanirbhar Bharat, Self-Reliant India program, leading to important substitution, the CSIR citation for Saikia Reed. Discovered accidentally in 2004, CQDs are small carbon nanoparticles with size less than 10 nanometer. Number of studies have been done worldwide in using fluorescent carbon properties, which have high stability, good conductivity, low toxicity, and are environmental friendly for various applications, including medicine and environmental sciences. His pioneering development of fluorescent CQDs of Indian coal is much cheaper than imported ones and helps to reduce dependency on other countries, thus bringing down the import of CQDs. Dr. Saikia has received Young Scientist Award by International Union of Crystallography in 2009. Rajiv Gandhi Excellence Award for 2012 from the Union Minister of Coal, Government of India, and ERAC Dr. Memorial Engineering Science Association of India Award 2014 by Mineral Engineering Science Association of India. He is holder of IIM Coal Beneficiation Award in 2015. Award for Honorable Mention, Technical Paper in International Pittsburgh Coal Conference, USA, and MESA, Mineral Engineering Science Association of India Award 2014, and Dr. R.P. Bhatnagar Award 2015-16 from the Mining, Geological and Metallurgical Institute of India for his outstanding contribution to mineral beneficiation. He is also recipient of Dr. M.P. Singh Memorial Coal Science Award 2019 for the outstanding contribution to coal chemistry and technology and Mineral Processing Technology Award. The Council of Scientific and Industrial Research, the apex agency of the Government of India for Scientific Research, awarded him the prestigious Santi Swarup Bhatnagar Award for Science and Technology, one of the highest Indian Science Award in 2021, for his contribution in the field of science and technology in the Earth, Atmosphere, Ocean and Planetary Science category below 45 years of age. Dr. Saikia is the 5th person from Assam to beg the award after Dr. Mihir Kanti Chaudhuri, 1989, Dr. Jitendranath Goswami, 1994, Dr. Rupendranath Goswami, 1995, and Dr. Prashant Goswami, 2001. Assam Governor Professor Jagdish Mukhi felicitated and congratulated Dr. Binay Kumar Hoikia for being conferred on the Santi Swarup Bhatnagar Award 2021. He has more than 110 peer-reviewed research publications with the highest impact factor of 10.588, having more than 2,500 citations. He is also associated with many science journals, national and international. He has also received several appreciations from Springer and Elsevier, American Chemical Society USA, Academic Journal Nigeria for his contribution. He has 5 patents, 2 US and 3 Indians. He has been handling multiple R&D projects and currently holds 4 ongoing R&D projects with external R&D funding obtained up to 10.50 crores. He is mentoring several doctoral research in their researches. We wish him good health, happiness, and a happy, contented family life. I am happy to share that they are blessed with a Lakshmi few days back. We also wish good health and best wishes for the newborn princess. Thank you very much.
Thank you so much, Madam, for presenting beautifully the life and journey of Dr. Binay Kumar Saikia. May I now invite our guest speaker, Dr. Binay Kumar Saikia, to deliver his lecture on revisiting coal and science technology for sustainable development.
A very good morning to all of you. The respected Honorable Vice Chancellor of this university, Register, Dr. Jiten Hazarika sir, and the Honorable our Union Minister, Dr. R. Singh, and the Head of the Division of the Applied Geology, and the senior faculties, and Professor Kalpana Madam, and all the faculties from the other departments, research scholars, and students. So it gives me an immense pleasure and happiness to be today in this university, not only as a guest or something, but as alumni of this university. Since I was awarded the PhD degree by this university in 2008. So actually, before I, মই ভাবিছিলোঁ যে there will be, I don't know, all are from the postgraduate students, but I think basically will be faculties and the research scholars will be more. So I thought I made a long presentations, but I will skip. So before that, মই ভাবো অকমান মই ক'ব খুজিছোঁ the journey of my journey and also some of my experiences with the research, which may be also useful for the faculties. Particularly young faculties. So actually, I I was enrolled for PhD in 2003 in this university. So in enrolling also I have, experiences. And that experience made me, or more experience I got. Kothato moi kobo khujisu, I'll be speaking in both languages because I want to speak in Assamese. So, jetia moi pass korilu, master degree pass korilu Guwahati University pora. There is a PhD koribor karone moi North East Institute of Science and Technology as a JRF project hisabe join korilu. And what is happening? One incident that I got a project under a scientist in a different discipline, not like a chemistry, because I am a postgraduate in chemistry. Basically, by profession, by academic qualification, I am a chemist. So, tetia ki hol je chemistry manuhe keneke etia beleg eta line of research koribo. So then at that time in NIST there is no PhD university, but now our CSR is a research university and only one research university in the country. So তেতিয়া মই কি কৰিলো ডিব্ৰুগড় ইউনিভাৰ্চিটিলৈ আহিলো for the to take a guidance to take registration. তেতিয়া কি হ'ল মোৰ I'm happy to say that my guide was a man of he's from physics. So then somebody suggested me to go to physics. So I went to the physics department of this university. Then somebody told, no, it's interdisciplinary, you are a chemistry postgraduate, so how you will be registered in physics? So this makes me a lot of, experience on me. So then I again come back to the chemistry department. So then the Podibugoi sir was very supportive and, very encouraging, particularly for that in interdisciplinary work. So at that way, my kobo khushu it is interdisciplinary, multidisciplinary research are now going to be rolled in the next 5-10 years. Ami chemistry, physics, geography, geology, we have to think holistically, we have to think everest. So ei kotha khini moi mane ei Dibrugor University lo jorito karone kobo khushu. So maybe that experience made me to work on a multidisciplinary which contains not only chemistry, not only physics, but also geology. So this is the experience on the research. Aru eta moi kobo khoju itu moi bhabu one of my best experience for particularly for the students. Always we think for the resources. We always still know how I can do research, how I can do this business, how I can do this, because there is no resources, there is no transportation, there is no raw material, there is nothing. So hei kotha khini jetia particularly this actually the most the most recognized work is the coal-derived carbon quantum dot. So when I was working on our team was working on the coal-derived carbon quantum dot, our NIST does not have a transmission electron microscope. Our NIST does not have an electron microscope. So at that time we discovered the carbon quantum dot from coal. We went to Shillong, went to Nehu, and we stayed 5 days, 10 days, and maybe chemistry person will know how difficult to get a electron microscope in Nehu, because you have to book before 2-3 months. You have to book a slot before 2-3 months and then go by vehicles 6 hours, 5 hours journey and stay in the hotel and do analysis. So resource, this should not be difficult for us. We have to cross this border of hurdles. Our facility nai, infrastructure nai, but not infrastructure, the resources, the scientific is not a problem, because we have a fund. Fund is not a problem in our country. I think I should not be incorrect, or because Honorable Minister is there. Our government is very much supportive for giving funds for a potential project or a potential things. So let me start these presentations. These two things I want to share. So basically, this is why revisiting, because jetia moi coal project bilak kobat koribole goisilo aji 5 বছৰ 10 বছৰ আগতে, ফার্স্ট বাইকটো আসলে নেগেটিভ, আরে কোল তো জ্বলতা hai. Everybody stayed in Delhi to me, why you are doing coal? Coal is burning, we are getting electricity, nothing to do with this. So that is I put this word revisiting. This gives something that yes, the person wants to revisit, or what you want to show, let me see. So my first project when I defended to Research Council of North East India, our institute, Research Council, the chairman told me that why you are working on coal, because nothing to do. What we will get in the coal? It's burn and we get electricity. So these things, then I think that what will make such people will, attractive on how their sustainability, how our, economic or the social task can be obtained. That's why we have worked, and this was also an incident because when we were working on the desulfurization of coal of this region, our coal, amar coalot bahut sulfur ase, we all knows. The first point somebody will tell that yes, Assam coal contains sulfur. So our former HODs, former scientists were trying to remove this sulfur from this coal, and I was also joined as a scientist, and I was trying for almost 4 years how to remove this sulfur. Then in 2015, I thought that no, we should not work on sulfur anymore because it cannot be done. It has been done for 50 years, so stop it. So I stopped the removal of sulfur, and it was approved by the Research Council that there will be no work on desulfurization of coal. Then we have worked for the value addition of this coal, and we tried to make something multidisciplinary approach. That is why I want to, and this title actually, by the title, Ghopke WhatsApp issue. So maybe, how sustainability is relation, how related. Like next slide of so basically coal is black, I told you. These are known things, everybody coal to ki ase. Coal to tekunai, it's black, dirty. So that is, but coal is also different colors. Just I want to tell those don't know, the students and chemistry and physics, some other person may not know, coal is not only black, it has different colors. To make this presentation little relaxing, because I found in literature that coal having different colors. So, and because this is the, my journey with the value addition of coal or the unique, analysis, unique research on coal. You can see this fluorescence image in the below slide. This was actually, there is also a story. This was done in this university. This spectra was done in the Department of Physics, Dibrugad University. Dr. Z.D. Borua was at the time. And when I approached him, then he was very much interested. Yes, I want to see the fluorescence behavior of coal. You just give me samples. Then he took few samples, and I was also present during the taking the images. I think that equipment is very, very old, and there is no microprocessor base. There is only camera, still camera. But this, this paper was immediately published in the American Chemical Society when I reported that coal contains these red colors due to the nitrogen or the other complexes. So, and at that time, Dr. Z.D. Borua told me that the fluorescence of coal is going to be, give a newer results, which now we have got from the study. So, I have, Jubilee University had a lot of contribution to this work also. So this is the latest figure, you see why we cannot stop coal research. Because the countries, you can see, India itself has proposed, 200 gigawatt power from coal for next 5 or 10 years. And you can see that India, China, and because slide told the Philippines, Vietnam, Turkey, Philippines, sort of countries, South Africa, they are planning for coke-based power plants. So we have to think for the, how to make it cleaner and how to stop this pollution. So, but it is an old data, but you can see very interesting, you see how coal is increasing green in other terms, because by utilizing these coals, people economics improving in terms of population, energy consumption, or the emission, because in comparison to earlier, the CO2 emission has been reduced due to latest technology of the boilers. So this is also a very recent paper from news magazine. I found that India is going to be increase the consumption of coal. And this is just, this was coal exchange were there, and now it is a hotel. I just got attraction, that is why I put it in the slide. Now this is a hotel, and I have seen that now also we can book rooms in the coal exchange. So this is, we all know, and how the economy, this is very good, we all know. And some coal companies are also there, this nothing, this is a history I want to just to share to the students, only for the students. And also dogs were used in the coal mining, we all know, and also in the Second World War, coal was a vital playing role. And the birds were utilized in mining for the direction, like now it is GPS. And also coal picking manual things are there. And also coal-inspired drinks were also there at that time. So how coal has been played the revolution and the town committee, and also coal tar is a medicine. This is very important. This is also because coal tar has been used as a medicine, so there is a chemicals, how to extract it. And then, coal, anything can be, that is a big sentence, anything can be get from coal, but we have to apply. And this is, I think may not know some people, why it is Margarita, why Margarita and Kanaka. So that queen, she was Queen Margarita from Italy. So she came, Sonto Paharu Society, Sonto Tek, Aisile Margarita. The people of the coal mining of Margarita has made a pizza. And that means the pizza was named the Margarita pizza. That from that Margarita, it becomes a Margarita. So she was the only, because of the Queen Margarita visited the place, now it is called Margarita. But the chemistry, if we go for chemistry, coal has 140 molecular models. It has a molecular structures, how carbon is arranged, how the hydrogen, sulfur, a lot of models, but nothing can establish the correct things. So that was what is the coal future. Then we have to rethink. That is why when I myself try to rethink and to make a innovation from this coal classical data, we found that it has a very aromatic and aliphatic structure. It has carbon, hydrogen, nitrogen, and also sulfur. So, and also inorganic elements are there. And then the latest challenge, the modern the latest challenge is to get the high valued or the very costly the nanomaterials, and particularly the carbon nanomaterials, because we have a lot of nanomaterials, that is traditional nanomaterials today we call, a lot of metallic nanomaterials. But thing is that these nanomaterials are toxic. These nanomaterials cannot be utilized in health science. These materials cannot be utilized in medical science, in diagnostic purpose, because these metals, cadmium nanoparticle, silver nanoparticle, whatever it is, it from a level of concentration, it has a tremendous toxicity to the human body. It cannot be utilized in drugs. But the carbon nanomaterials, because of its low toxicity and biocompatibility, it has been a various demands nowadays. All universities, IITs, IJAR, NIJAR, they started to work on carbon nanomaterial. You can see the papers. So that is why I thought that if these carbon nanomaterials can be synthesized very easily with this low, abundant material, that will be challenging. So I started this project and applied to the CSIR. We got a fund of 3.2 crore fund from the CSIR, and we started the project. This is the group leader currently. Then why the nanomaterial? I already told you. Why the nanomaterials is future, the carbon nanomaterial is future. So because of this, you see, and it has tremendous application in all the fields. In any field, science or biomedicine, catalysis, there are a lot of fields because of the low toxicity. And because of the water solubility, it is soluble in water. So because of that, I'm planning to utilize coal as a precursor. And also then came to the method, how to utilize the method. Because in literature, there are all the types of methods are available. But thing is that if we have to go for commercialization, if we go for industry establishment, then the method should be economically feasible and also simple, less step. Then I found that the chemical method is only the best suitable method. You can see in the right side, the chemical method will be the best soluble, which best method. And also the ultrasonic energy, which does not require the other harsh chemicals or the extra electrical energy. Then the ultrasonic and chemical, we combine it, which is easy to operation and less environment to the environment. So that is why then we have, that was also incident. I told you that when I was working in desulfurization coal, one day we found that during the course of reaction of desulfurization, we found the carbon quantum, the blue fluorescence, the blue luminescence carbon nanoparticle in a beaker. So that was the journey, and we go to the NEHU. I already told you how difficult was the time. So basically, I will just give the properties. This is I already told. You can see the six most exciting properties. One is it has a good optical properties. I mean, in visible light, it is colorless, but if we expose to external source of light, UV light or laser light, then it gives a different color. That means we can use this carbon quantum dot as a diagnostic purpose. And because of the non-toxicity, because of the water soluble, it can be applied to the health science, to the medical science. But that is a long journey. But it is that if there is a scope, and another is economy. I will go to the next slide, how economic benefit is there. So then the process was developed in the project, and this was also filed a patent, and also recently it was granted from US 2020. This patent was granted, and this was some of the properties. I want to say that, you know, how much carbon is present in coal, if some discipline they may not know, and also how the chemical structure of coal, you know, it has a graphitic structure. I will not much elaborate. And also, interestingly, it has the functional groups, which is most important for, you know, activity, important for its activity, and also the optical properties. Also the binding with the targeted site or targeted things. So this functional group and the graphitic structure are already present in coal. Only we have to exploit it to required nanomaterial properties. So this is the, after when we synthesize the carbon quantum dot, these are the carbon quantum dot, the spherical size, and basically carbon quantum dot are less than 10 nanometer size. These are smaller than 10 nanometer size. And this is nothing but the nanocrystals of carbon, you know, and there is nothing other than the oxygen and hydrogen. But in case of our coal-derived carbon quantum dot, we have also nitrogen, which is very, very important for other application like, you know, doping or functionalization, catalysis. So you can see this in the visible light. These are the coal-derived carbon quantum dot, and under UV light there is a fluorescence. So because of the optical property, it is very interesting to apply as a diagnostic material. So these are the similar study with the doped sulfur and nitrogen doped. We have also doped the, not doped, co-doped. I mean the researchers are making carbon quantum dot by doping the nitrogen and sulfur from outside. But from coal, it is already doped. So we are extra, you know, benefited where it is already made. So there is also a, you know, directly utilize these things if nitrogen and sulfur is important for us in terms of application. So this explanation I will not go detail, but the main things is that, you know, these are carbon and hydrogen containing functionalized carbon quantum dot, which is very, very essential now in the present, I mean current demand. So this was also from another samples, because we have tried a lot, varied you know, coal samples with the location, with the carbon content difference, with the also seam wise also we have studied, because from geologically, one geologist will definitely ask me what is the coal to, you know, coal as a tons of coal is a big seams are there, what is the difference between Chinese coal, US coal, Indian coal. So we have tried with seam wise, and also we have tried with the types, you know, ranks of coal like subbituminous, bituminous, anthracite. And by the grace of God, anthracite coal does not give the carbon quantum dot. So we are the grace of God. I mean, these coal are very, very, you know, lacked for this reason. This tertiary and the younger coal are very, very easy to exploit to the carbon quantum dot. So you can see some of the work I compared with the other literature, and found that we are in the higher side of this property in terms of quantum yield and other parameters. And then we also determine as a chemist or as a optical physicist, you ask for the quantum yield and what is its optical efficiency. Then we found that up to, in this example, it is 9.95% of quantum yield, but we found up to 16 to 17% of quantum yield. And because of that quantum yield percentage, the Sigma LD company has attracted us, because their carbon quantum dot is having less than 10% of quantum yield. So they are interested to buy our technology because of our higher quality parameters. And then second, just I want to share, this is also a innovation, just I want to share with the students and young faculties. You know, the air pollution, like the atmospheric particulate matter, which is called particulate matter, and this is a very, very, you know, is a harming, very dangerous to the people for Now it is already dangerous in some like Delhi, Bombay, but in Northeast also, now we have been affecting by the, this atmospheric pollutant. This atmospheric pollutant, particularly if we go for the aerosols, then we have 3 types of particulates. Less than 2.5 micron, 10 micron, and 1 micron. Then we are also having one project from Ministry of Environment and Forest, New Delhi. In that project, we are the only institute to monitor the aerosol for continuous for 2 years under the National Carbonaceous Aerosol Mission. I think Jubilee University also has been working on this area, particularly in modeling. So in this project, as a chemist, I thought that this is also a carbon. Aerosol is also carbonaceous aerosol, black carbon. So this is also a carbon, and this is a waste, and this is a pollutant. Why not to convert this waste into waste into value-added products, and see what is happening in their mechanism and how the carbon will behave to a chemist. Then we started a project in the CSIR, and we found that these aerosols or these carbonaceous, this black carbon can be converted into nanodiamonds. So because in Delhi now 4 or 5 spoke towers has been installed. In the spoke tower, they absorb the dust particles, and these are nothing dust particles. So they have a plan to reduce the emission in Delhi. So in that line, I thought that if this black carbon can be converted to waste, then maybe in future, it's a long run, but maybe in future there will be a technology for converting the waste into wealth or some value addition, or particularly the mitigation of air pollution, reduction of air pollution. So in this case, then we started also work on coal. Coal also I tried first actually. Because of this process, I go into this dust particle. In that nanodiamonds, coal to nanodiamonds, we have also developed the process. In the same process, then we converted the coal particle into nanodiamonds. Actually, what happened? These nanodiamonds and carbon quantum dots are, there is a no such differences, but only difference with the size. And also, it's a very challenging actually. If we can separate the nanodiamonds from carbon quantum dot, then it's a challenging. It's a big challenge, because these nanodiamonds are far more better than carbon quantum dot. Because in foreign countries, I have seen many journals and many medical science journals, they're utilizing nanodiamonds for detecting the cancer cells, the cancer diagnostic tool. So it's a very demanding, but we don't know how much we have success, but there is a probability of converting this type of this region coal into the nanodiamonds. And we compared with the standards. We compared with the standard nanodiamonds, and we found it from the electron microscope as well as the EDS elemental study. We found that these are as per the standard nanodiamond sizes, carbon at distances as well as the lattice sizes are in as per standard nanodiamonds. Then what I wanted to tell you that this is the mechanism. If somebody wants to know, because you see this mechanism is a postulate. We just assume, we just think that because it's a very heterogeneous chemistry, we assume that when we are doing oxidation, because coal is having this type of structure, subbituminous coal, then we are oxidizing in terms of external energy like ultrasonic wave, then it breaks, because ultrasonic wave breaks the bigger particle in the smaller one, then this bigger particle in the smaller one, then at the same time there is a CC bond cleavages, and also the functionalization occurs. This is called something, somebody called it a metamorphic reaction. At the same time, breakage as well as formation happens, and we got the carbon quantum dot from coal. So this is a process. We already have a prototype plant in our institute. It is about 1 liter per batch production of quantum dot from coal. Technology is already transferred to the Sigma Rig. And also, because I was telling that how it is important for medical science diagnostic tool, then that is why we have studied the cytotoxicity, antibacterial, and also the DNA. Cell biology study has been done, and we found that there's nothing worry about the cell damages or the DNA cleavages are not there when using the coal-based carbon quantum dot in comparison to the commercially available carbon quantum dot. And this was the preliminary study at the time we had done, that you can show these are the control cells, cancer cells, and we applied our own derived carbon conduct into cancer cells. We found that these have a different emission intensity as well as the emission colors. So on basis of the location of the cancer cells, definitely we can locate the presence of the cancer cells or the non-cancer cells also. So it is this carbon compound is already available in the market or already available such type of contrasting agent in cancer cell detection. But thing is that there is no use of such quantum dot from India in the detection of the cancer cells. So if we can replace such contrast agent by our quantum dot and can be proved by the medical doctors, because this type of research is require the assistance or the assistance of medical doctors. I do not have any medical doctors collaboration. So if it happens, then definitely there will be replacement of such international chemicals to the India, which will directly is a import substitution. So I will go to the economics, why it is possible to substitute the import. So these are the latest new study, because this carbon quantum dot also we applied as a nano fertilizer to study the plant growth. And we found that this carbon quantum dot, when sprayed with the plants, it gives growth, not only physical growth, but also in the effect or the enhancement of the metabolites, plant metabolites. Of course, these are collaborative studies, so I cannot speak much, but if somebody interested, I can definitely talk with the person. And this is a market study. And actually, doing a research, this market study is very, very important. That is why I kept this slide. I should keep this slide first. But why I want to keep this slide? Because to get this cold react carbon quantum dot, I have to present this slide to the CSIR, to the expert, why it is important. You can see that how much global market value carbon quantum dot has, and how much import, how much money is going outside, and how we can substitute the import. So you can see there is a business growth up to $3 billion by 2021. Of course, it is an old slide, but definitely it is increased by double or triple. So these are the applications which has been used by use of carbon quantum dot. And this, you can see the Sigma Aldrich. The Sigma Aldrich company has, about 10 ml, I mean 1 ml, 1,600, I mean 1,600. But our cold react carbon quantum is only 50 rupees per ml. So this was the technology. That is why we can sell it on 50 to 100 rupees per ml, whereas Sigma is selling is 1,500 per ml. So this is why Sigma Aldrich was very much interested. They called me 5 times over phone and video call, and they wanted to take our technology. So that is the thing. Market service is very, very important. This is the agreement with the Sigma Aldrich. We made it in 2017. Thank you all. So, if anything, I will go into the can explain.
Thank you so much, sir, for your wonderful, inspiring, and very dynamic lecture. We are very much thankful to you, sir. In spite of your busy schedule, you are here with us for the lectures. We are indeed very much honored and pleasure to congratulate you on your success and receiving the prestigious Santi Swarop Bhatnagar Award. We would like to congratulate you on your success on the behalf of Department of Applied Geology and the Dibrugarh University Research Scholar Association and the Dibrugarh University. We would like to present you a memento of congratulation and a token of gratitude as our respect, as our gratitude, and as our appreciation to you, sir. May I now request Ms. Pallavi Borkakuti and Ms. Malobika Bora to read the congratulation messages and token of gratitude. 4th Golden Jubilee Lecture of Department of Applied Geology, Jubilee University, to Dr. Binoy Kumar Saikia, FIC, Senior Scientist and Assistant Professor, CSIR, HOD, Coal and Energy Division, CSIR NIST, Jorhat, Assam, and recipient of prestigious Shanti Sarup Bhatnagar Award 2021 in the Art, Atmosphere, Ocean and Planetary Science category. Dear Dr. Saikia, warm greetings from Jubilee University. It is indeed a moment of great honor that we, all the members of Department of Applied Geology, the Jubilee University Research Scholars Association, and the entire Jubilee University fraternity are gathered today to extend our heartiest congratulations to you for making us all proud by being the recipient of the prestigious Shanti Sarup Bhatnagar Award 2021 presented by the Council of Scientific and Industrial Research, Government of India in the Art, Atmosphere, Ocean and Planetary Science category to researchers below 45 years of age. Dr. Saikia, you are one of the rare gems who, with a very humble beginning in your own homeland, have been able to bring back a host of laurels to make yourself, your family, and all of us here in Assam incredibly proud. Your journey through many challenges shall be etched in our hearts forever. Your hard work, dedication, perseverance will always be an inspiration for young scientists and researchers across disciplines. We once again accord our felicitation to you for your exemplary achievements and wish you good health, happiness, and a contented family life. May you continue to shine and may we be blessed with more such occasions to celebrate your success in the very near future. Professor L.K. Nath, Vice Chancellor in charge, Registrar Professor Jiten Hazarika, Professor Kalpana Dekakolita and Dr. Diganto Bhuiya, conveners, Mr. Vidyutjyoti Dotto, President Dursa, Mr. Bhaskar Saikia, General Secretary Dursa, Ranghor, Dibrugarh University, 11th April, Tuesday, 2022. Thank you.
A token of gratitude presented to Dr. Binoy Kumar Saikia, FIC, Senior Scientist and Assistant Professor, ACSIR, HOD, Coal and Energy Division, CSIR, NIST, Jorhat, Assam, and the recipient of the prestigious Shanti Sarup Bhatnagar Award 2021 in the Art, Atmosphere, Ocean and Planetary Science category for delivering the 4th Golden Jubilee Lecture of Department of Applied Geology, Dibrugarh University, on revisiting coal science and technology for sustainable development, organized by Department of Applied Geology and Dibrugarh University Research Scholars Association, 11th April 2022, Ranghor Auditorium, Dibrugarh University. Thank you.
Thank you, Pallavi. Thank you, Malavika. May I now request Professor Kalpana Dekakolita, Madam, to present a memento to sir. Thank you, ma'am. Thank you, sir. May I now request our head of the department, Dr. Diganto Bhuiya, sir, to present a token of gratitude to our guest speaker. Thank you, sir. Now, on the behalf of the chairperson, Center for Atmospheric Studies, Dr. Binodya Pathak would like to take this opportunity to felicitate Dr. Vinay Kumar Saikia. Thank you, madam. Thank you, sir. Next, we have an interactive session with our guest speaker, with our research scholars and students and the members present here. I invite Mr. Vidyut Jyoti Dutta, President, Dibrugarh University Research Scholar Association, to take over the session and moderate the interactive session.
নমস্কাৰ আজিৰ প্ৰায়োগিক ভূতত্ত্ব বিজ্ঞান বিভাগৰ চতুৰ্থতম সোণালী জয়ন্তী বিশেষ বক্তৃতা অনুষ্ঠানত উপস্থিত বিশ্ববিদ্যালয়ৰ সন্মানীয় উপাচাৰ্য মহোদয়, সন্মানীয় পঞ্জীয়ক মহোদয়, বিদেশ পৰিক্ৰমা তথা শিক্ষা দপ্তৰৰ কেন্দ্ৰীয় ৰাজ্যমন্ত্ৰী ডক্টৰ ৰাজকুমাৰ ৰঞ্জন সিং ছাৰ, আমন্ত্ৰিত অতিথি তথা উত্তৰ পূব বিজ্ঞান আৰু প্ৰযুক্তি প্ৰতিষ্ঠানৰ সন্মানীয় জ্যেষ্ঠ বিজ্ঞানী ডক্টৰ মনোজ ফুকন ছাৰ, আজিৰ অনুষ্ঠানটিৰ বাবে আমন্ত্ৰণ কৰা সন্মানীয় শান্তিস্বৰূপ ভাটনাগৰ বঁটাপ্ৰাপ্ত বিজ্ঞানী ডক্টৰ বিনয় কুমাৰ শইকীয়া ছাৰ, আজিৰ অনুষ্ঠানটিৰ আহ্বায়ক তথা প্ৰায়োগিক ভূতত্ত্ব বিজ্ঞান বিভাগৰ সন্মানীয় মুৰব্বী অধ্যাপক ডক্টৰ দিগন্ত ভূঞা ছাৰ আৰু কল্পনা ডেকা কলিতা বাইদেউ, বিভিন্ন বিভাগ তথা কেন্দ্ৰৰ সন্মানীয় শিক্ষাগুৰুসকল, গৱেষকবৃন্দ আৰু ছাত্ৰ ছাত্ৰীসকল তথা উপস্থিত অতিথিবৃন্দ, আজিৰ এই বিশেষ অনুষ্ঠানটিত শ্ৰদ্ধাৰ বিনয় কুমাৰ শইকীয়া ছাৰে আমাক তেখেতৰ অভিজ্ঞতা আৰু তেখেতৰ গৱেষণাৰ সম্বন্ধে বহুত ধুনীয়াকৈ আমাক বুজালে, এটা বিস্তৰভাৱে আমাক আভাস দিলে। গতিকে তেওঁ কেনেদৰে নিজৰ সুপুৰুষাৰ্থৰ ফলত নিজৰ বৈজ্ঞানিক দৃষ্টিভংগী তথা নিজৰ কষ্টেৰে আজি শান্তিস্বৰূপ ভাটনাগৰ বঁটা পাবলৈ সক্ষম হৈছে, গতিকে তেখেতৰ যি পৰিক্ৰমা, তেখেতৰ যি বৈজ্ঞানিক চিন্তাধাৰা বা তেখেতৰ যি বৈজ্ঞানিক মানসিকতা তথা তেখেতৰ কাৰ্যকলাপসমূহৰ বিষয়ে আমাৰ জানিবলগীয়া হয়তো বহুত আছে। গতিকে মই অনুৰোধ জনাইছোঁ আমাৰ ছাত্ৰ ছাত্ৰীসকল তথা গৱেষক ছাত্ৰ ছাত্ৰীসকল আৰু আমাৰ শ্ৰদ্ধাৰ শিক্ষাগুৰুসকলক আমাৰ শ্ৰদ্ধাৰ আমন্ত্ৰিত অতিথি ডক্টৰ বিনয় কুমাৰ শইকীয়া ছাৰক তেখেতলোকৰ কিবা মনোভাৱ তথা তেখেতৰ কৰ্মৰাজিৰ বিষয়ে জানিবলৈ ইচ্ছা প্ৰকাশ কৰিলে আমি সন্মুখলৈ আহি তেওঁলোকৰ প্ৰশ্নসমূহ উত্থাপন কৰিবলৈ অনুৰোধ জনাইছোঁ।
Thank you, Dr. Vinay Kumar Saikia sir, for the very interesting talk on revisiting coal science and technology, and particularly your discovery of the Q dot from coals. May I know, are the tertiary coals suitable for this purpose than the Gondwana coals? Because there are certain differences between these two types. Which one is better?
Yeah, this is a good question. We have tested for different types and ranks of coal. And Gondwana coal, in concern to Gondwana coal, actually, if we go to the chemistry of coal, we found that the tertiary or, tertiary and Gondwana are the ages. If we go for this chemistry, like bituminous and the anthracite, such type of ranking, we found that this, our subbituminous, the northeastern coal is easy to exfoliate, you know. And when I have done my PhD, I also applied the X-ray diffraction technique, like the radial distribution function analysis, to see how carbon atoms are distributed. And I found that in these coals, the carbons are, you know, they have a layer which we could not say graphene layers, but we could say the turbostatic layers are there. You know, the random layering are there. And these layers can be easily breaked by chemically, so that we can get small crystals of carbon. And hopefully those, well, why I'm telling hopefully, because, you know, it's interesting, I told you, by luckily those crystallites are converted into carbon quantum profile. So I can say yes, tertiary I cannot say, but I can say the coal of the region, subbituminous, or the chemistry, the unique chemistry of this region is unique for producing the graphene as well as the carbon quantum profile.
Now, why I am asking, CFRI in 1970, Dr. Lahiri has done a very important work for syn crude production. Syn crude production from tertiary coal, because of its very peculiar composition, which has been tried in South Africa and other countries. They are producing syn crude from the this kind of abnormal coals. So in that way, I think tertiary coal is very important. And besides, its tar production is much more than the gondola. So we are not looking into that aspect still. Though research has been done long back, we are not looking into that, the very importance of the tertiary coal.
Yeah, power production actually, what happened, because when I visited CMPDI, the nodal agency of the government of India to look after the coal mining, so because they also don't know all the things, they told me that you know, our coals are shortage. There is no supply chain for the power plant. But Nagaland, Meghalaya and Arunachal Pradesh also, because particularly Nagaland and Meghalaya has a huge deposit of coal. Yeah. But because of the, you know, issue of accessibility, mining, remoteness, transport, these things, it cannot be utilized. But thing is that this, because of the sulfur issue and the shortage of coal, these coals are not, they are not taking this coal for the power plant. In Bangaigaon, NTPC, it was established to use the northeastern coal, but because of the lack of supply chain, that could not be done, and they have taken the coal again from Zaria. So there are two things. One is pollution because of the sulfur, because, you know, fluidized bed combustion techniques are there, but also there is a pollution concern for the sulfur disposable. That is why these two issues are there. It is my personal point. So one is the shortage, and maybe another is the sulfur. And that two things made us to think in a different way, to rethink the coal for utilizing in other areas where the demands is there.
You have mentioned about the desulfurization technique for removing, extracting sulfur. Because we are shortage in sulfur, in resource. In terms of resource, you have mentioned that you tried on that particular technique once, but later on you have not continuing this thing. Is it not feasible, or some other reasons are there why you have left that particular part?
No, why I stopped? Because I attended one engineering conference in Guwahati. All are engineers. So they asked me, what are you doing? Then I told, we are working on desulfurization coal. Why desulfurization? The engineer told me, I will take care of sulfur. You forget it. You give me the technology of power plant, combustion. How we utilize in power plant. Because sulfur they can recover and they can convert into fertilizer. So this also one strike. If engineers told me that why you worry about sulfur, you burn it, we will recover the sulfur, we will make calcium sulfate, ammonium sulfate fertilizer, So that is the thing I thought that yes, there is a integration problems are there, the engineers and scientists, which is essentially needed for this reason. Otherwise, one scientist cannot be a businessman, one scientist cannot be a technologist. Engineers are definitely required and multidisciplinary approach is required. You are right. You are rightly mentioned that we have to work on sulfur because sulfur is an essential component of fertilizer. So why we are stopping if we can get the sulfur from coal and we can make fertilizer? That is true. But because of the time and thinking, I stopped. We stopped that research. We worked on the value addition because value addition will make the economic development.
Okay.
And give price to the coal company.
I also agree. But another thing you mentioned that is the nano diamond.
Yes.
In laboratory scale, what are the conditions required to convert it? A very high temperature apparatus will be required, or some different kinds of processes related to it?
No. High temperature, high pressure method we are not applying. This is a very costly method. There is I show in one slide, HTTP, high temperature and high pressure method. If you go to that method, then it will be very costly. You require a lot of infrastructure and this. We are only using the chemicals and the ultrasonic energy. Ultrasonic energy is taking a great role in making the particle size to the nanometers or the carbon monomer. But there is a technique of ultrafiltration. Somebody can ask why, how we purify it. So ultrafiltration technique is there to filter, to separate the particles.
Okay. Thank you, sir.
Thank you much.
Yes, to just continue with my small comment. Basically, I was curious after listening to your talk, which is very important, and since you also emphasize on the need of interdisciplinary kind of approach, and I come from the discipline of political science, and we actually teach papers like ecological politics and the issues of environment, and this is extremely crucial for us also because, as you know, this has been one of the very volatile and kind of vibrant issue of late. And how to look at our resources as also part of our identity and different type of mobilization that is happening. So I was just curious that since you, from hearing your presentation, perhaps I might be wrong, but and maybe elsewhere in the world also we see this development, then there is this kind of paradox that is developing. That is, on one hand, there is possibility of these different resources to be used as clean energy, because you also talk about sustainability and sustainable development. So can we see that issues like recent controversies and this kind of debates that are happening about new mines and new excavation, digging Patkai rainforest excavation, etc. Is there a kind of a paradox that on one hand we are trying to promote this as source of clean energy, but at the same time it is also posing a threat to some kind of endangering some other kind of eco habitats and ecosystem. I mean, maybe it's not exactly part of your talk today, but since you talk of sustainability, I thought since from the perspective of interdisciplinary lens also, and we would also like to understand these issues more, and therefore it's very interesting and important this type of dialogue between disciplines. Thank you.
Yeah, political science, the politics is what my perceive is the most required things for the economic development. A good political system, if they understand the scientists, if they understand the doctors, if they understand the researchers, in the COVID time in Germany, one scientist told the Prime Minister that you go to a football player and take the help from a football player because he gets more money than a scientist, than a researcher. So politics, what I'm telling is, yes, of course, a political analyzer or a political science student of this region definitely can have a, expose the resources which can be utilized for the development of the society of this region, particularly coal. And if, what I understand from your question, one thing that how it relates to sustainability, what if I am correct, in COP, the last COP conference, COP meeting, the countries have given the target of reduction of CO2 emission. So as far as I remember, that India is targeting in 2030, I think. 2030, they will reduce the carbon dioxide emissions. And by 2070, definitely I will die. I don't know. So 2070 it is zero. So you see how political systems are targeting and what is the influence. You know, this targeting not given by scientists and politicians. With the help of, definitely with the help of a scientist or researcher. So definitely these type of things are related with the utilization of the resources. So as a political science or the economist, the region's sources or resources can definitely be come into the national level. And another important in this context of the question, I would like to state it that, you know, definitely if there are students, particularly for the students I am telling, you have to showcase yourself. Not, you know, there are three types of showing the potential or showing the resources of these regions. One is international, then one is national, then it's regional. So what we are doing, what I think we are discussing regionally all the things. We are not discussing the things nationally and not internationally, not even nationally sometimes. So carbon quantum dot is an international market. So the resources is local. So you have to work on the local things, why it should have international impact. So who will give the internal impact? The political scientists, students, political faculties, economists. They have to taken it up to the international level. So very, very important, like a person like you. So if we are working on regional issues, then there will be nothing, any impact in national and international. Because yes, this is of course true. We have to be and that is indigenous. That is related to the Atmanirbhar Bharat. That is indigenous. So if you are working on indigenous and domestic things with the international level, then definitely it will have a broader impact. I could not, I think I am not able to answer your question because you but I think in general, I think you understand.
Thank you.
ধন্যবাদ জানাইছোঁ আমাৰ গৱেষক ছাত্ৰ ছাত্ৰীসকল আৰু ইয়াত উপস্থিত ছাত্ৰ ছাত্ৰীসকলে ছাৰক উদ্দেশ্যি যদি তেওঁলোকৰ বিজ্ঞান সম্বন্ধীয় বা কিছু কথা জানিব বিচাৰে তেন্তে মই বিনা দ্বিধাই সুধিবলৈ অনুৰোধ জনাইছোঁ।
নমস্কাৰ ছাৰ, মোৰ নাম শ্ৰী বাৰ্লিন দাস, মই পদাৰ্থ বিজ্ঞান বিভাগৰ এজন গৱেষক। পোনপ্ৰথমে আপোনাৰ স্বাগত জনাইছোঁ ডিব্ৰুগড় বিশ্ববিদ্যালয়লৈ। মোৰ কুৱেশ্যনটো হৈছে, আপুনি ক'লে ছালফাৰ যোনটো আমি ৰিমুভ কৰিব বিচাৰি আছোঁ কলৰ পৰা, সেই বস্তুটো ষ্টপ কৰা হৈছে, কিন্তু ছালফাৰ আমি যিমানে আমি কনজাম কৰি থাকিম, ছালফাৰ যদি কনজাম হয় তাৰ পৰা কম্বাশ্যনৰ ফলত ছালফাৰ হয়, এলিমেণ্টেল ছালফাৰ, তাৰ পৰা আমি ছালফাৰ ডাই অক্সাইড হয়। কাৰণ মই বৰ্তমান নিউ পাৰ্টিকেল ফৰ্মেশ্যনৰ ওপৰত কাম কৰি আছোঁ। কাৰণ ছালফাৰ ডাই অক্সাইডে যদি OH লগত ফৰ্ম কৰি H2SO4 হয়, তাৰপিছত সি ফাৰ্দাৰ ৰিয়েক্ট উইথ H2O to become a stable cluster, and if the situation right, if the conditions are right in the atmosphere, it will become an aerosol, and if the aerosol, it will participate on the aerosol mass, then the whole set of microphysics will come into play, like cloud condensation nuclei, ice condensation. তো কথাটো এনেকুৱা ধৰণৰ যে গ্লোবেল সাষ্টেইনেবিলিটি কথাটো কৈছোঁ, কিন্তু এই বস্তুটো যদি যিমানে আমি কনজাম কৰি থাকিম তেনেহ'লে এনভাইৰনমেণ্টত এটা নেগেটিভ ইফেক্ট পৰিবই। কাৰণ আমাৰ যোনটো আনচাৰ্টেনিটি আছে, আমাৰ যোনটো ৰেইনফলৰ ইভেণ্ট হওক, ক্লাউড এলবিডো হওক, ক্লাউড ফৰ্মেশ্যনৰ কথা হওক, এইটো আনচাৰ্টেনিটিটো কাৰণ তাত 3 to 70% নিউ পাৰ্টিকেল ফৰ্মেশ্যনে পাৰ্টিচিপেট কৰে। এনেই আমাৰ আল্ট্ৰাফাইন পাৰ্টিকেলখিনি ওলায়, যোনখিনি এটমছফিয়াৰৰ পৰা যোনখিনি আমি কয় ভেহিকুলাৰ এমিশ্যনৰ পৰা যি ধৰণৰ আল্ট্ৰাফাইন পাৰ্টিকেল ওলায়, কিন্তু নিউ পাৰ্টিকেল ফৰ্মেশ্যনৰ পৰা যোনখিনি ফাইন পাৰ্টিকেল ওলায়, ইটছ বেচিকেলি ইন সাব নেনোমিটাৰ ইন ৰেঞ্জ। চ' সেই পাৰ্টিকেলখিনিৰ কনচেনট্ৰেশ্যনটো বাঢ়ি গৈ থাকিব।
আপুনি কোৱা কথাখিনি একদম শুদ্ধ। সেইটো কাৰণেতো আমি ছালফাৰ ইনভেলটো ষ্টপ কৰিম। বিকজ তাত যদি ছালফাৰ থাকে, আমি যদি কোলটো কম্বাশ্যন কৰোঁ, সেই গোটেইবিলাক হ'ব, যিবিলাক আপুনি ক'লে SO2 হ'ব, ক্লাউড ফৰ্মেশ্যন, লট অফ পলিউশ্যন হ'ব। সেইকাৰণে আমি কি কৰোঁ যে এই কোলখিনি আমি কম্বাশ্যনেই নকৰোঁ, নকৰি পেলাই আমি ভেলু এডিশ্যন কৰোঁ। আমাক ফাইনেলি উই আৰ টাৰ্গেটিং টু দ্য ইকনমিক ডেভেলপমেণ্ট। 1 টন কয়লাৰ দাম 5,000 টকা। 1 টন কয়লা যদি 5,000 টকাত, মই জাষ্ট অলপ লাষ্ট স্কেলত কৈছোঁ দেই, তেতিয়া 1 টন কয়লাৰ পৰা যদি ইমানবোৰ কৰিলে ইমান পলিউশ্যন হয়, ৱাই নট টু বাৰ্ণ? I am not telling the stoppage of burning this all the coals of the world. মই কৈছোঁ নৰ্থ ইষ্টাৰ্ণ কোলৰ হাই ছালফাৰ কোল আমি বাৰ্ণিং কৰোঁ নকৰি পেলাই ভেলু এডিশ্যন কৰি পেলাই তাৰ কাৰ্বন নেন'মেটেৰিয়েল বনাওঁ গ্ৰাফিন বনাওঁ এতিয়া কি হ'ল এটা হ'ল ইনডাইৰেক্টলি এইটো পলিউশ্যন ইজ ষ্টপ বিকজ উই ডিড নট বাৰ্ণ তুমি আপুনি কোৱা কথা একোৱে নহ'ল আৰু ছেকেণ্ডতে হ'ল উই গট দ্য মানি বাট থিং ইজ ডেট আই ৱান্ট টু চে যদি কয় যে ইমান আমাক গ্ৰাফিন কেলে লাগে কাৰ্বন নেন'মেটেৰিয়েল কেলে লাগে তেতিয়া কথাটো বেলেগ হ'ব মই আপোনালোকক মানে মনৰ যদি কাৰোবাৰ কিউৰিচিটি হৈছে why we need so much carbon nanomaterial why we need carbon nanomaterial অকমানে লাগে ইমান কেলে লাগে সেইটো বেলেগ এটা প্ৰশ্ন কিন্তু আফটাৰ 10 years আপুনি কোৱা কথাখিনি যিখিনি ক'লে সেইখিনি এতিয়া কৈ আছে আফটাৰ 10 years গভৰ্ণমেণ্ট অফ ইণ্ডিয়াই ক'লে কোল বাৰ্ণিং ষ্টপ তেতিয়া আমি কি কৰিম তেতিয়া সেই কয়লাখিনিৰ পৰা আমি গ্ৰাফিন বনাওঁ কয়লাখিনিৰ পৰা আমি গ্ৰেফাইট বনাওঁ কয়লাখিনিৰ পৰা আমি কাৰ্বন নেন'মেটেৰিয়েল বনাওঁ চ' ইটছ এ অল্টাৰনেটিভ ইউজ অফ কোল টু ষ্টপ দি পলিউশ্যন এজ ট'ল্ড বাই ইউ আপুনি কোৱা কথাখিনি ৰাইট কিন্তু ছালফাৰ ৰিমুভেল কৰিবলৈ তাৰমানে কেলে ৰিমুভেল কৰিব খুজিছিলে ছালফাৰ ৰিমুভেল কৰি পেলাই কোলখিনি বাৰ্ণ কৰিব পাৰে কিন্তু ৰিমুভেল কৰিব পৰা নাই নহয় গতিকে বাৰ্ণো কৰিব পৰা নাই মানে পাৱাৰ প্লেণ্টত ইউজ কৰিব পৰা নাই গতিকে এটাও হোৱা নাই ইটো হোৱা নাই চ' হোৱাই টু ৱৰ্ক দিছ যে দুইফালে নহয় কম্বাছন কৰিব নোৱাৰোঁ ৰিমুভেল কৰিব নোৱাৰোঁ চ' উই আৰ ৱৰ্কিং ইন এ ডিফাৰেণ্ট ডাইৰেকশ্যন চ' উই হেভ টু থিংক একচুৱেলি we always have to think in a different way. If we follow the literatures, isn't it? If you follow all things, then nothing, there will be no innovation. We have to think in a different way. Konobai jodi cloud formation, SO2 pollution kotha koi ache. You people are working on the aerosol, this modeling,
actually
cloud formation. No, you know, some of the faculties, apni jodi bishot kole he bishot he kaam to kori ase. So moi hetu nokori. I thought for conversion of those black carbon into carbon negative. Because if I work in the same direction, how do I know it?
Thank you so much, sir.
ছাত্ৰ ছাত্ৰীসকলৰ মাজৰ পৰা কোনোবাই চাৰুগতিশ্ৰী তেওঁলোকৰ মনৰ ভাৱ পোষণ কৰিব বিচাৰিলে
Namaskar, sir. I'm Amarjit Borthakur. I'm a student of master degree in the Department of Chemistry. So my question is that, as you mentioned in your presentation, that synthesizing carbon nanodiamonds from aerosol. So by doing this in a large scale, is it possible to reduce the pollutions in India, like in a large city like Delhi?
Is it possible? It is a simple process. I have shown the flow sheet. Actually, concept to key, it is a new concept. And this is a new concept, I think, not only in India. One architect, sir, actually designed the first process. He was from Portugal or something. I have seen the first, YouTube. So what he was telling, that he will make a diamond out of air pollutant. That YouTube video mileage about. Diamond from air pollutant mileage, he was not a scientist, he was an architect, sir. So he video to was high he will make a diamond out of the air pollutant. Air pollutant to black carbon. So tekhete kintu eta high pressure high temperature eto okoman agote kole high pressure high temperature method use koribo. So that is also given me some idea that I told my research scholar that why we will not apply chemical synthesis, chemical method. Today I made a simple it is already filed. Hydrogen peroxide or oxidation koribole tak you can convert it to nanodiamonds. Ultrafiltration and ultracentrifuge technique duta ase mazot khali. So hetu koribole koribora. I think if somebody wants to make a scale up, এটা Delhi যিটো স্মোক টাৱাৰ আছে তাতো সেই ব্লেক ডাষ্টবিলাকে জমা হ'ব গতিকে আমি যদি তাৰ পৰা এটা ইণ্টিগ্ৰেটেড চিষ্টেম বনাই দিব পাৰোঁ সেই কাৰ্বন ডাষ্টখিনি সেই প্ৰচেছটো গুচি গ'ল I think it can be scale up but before going to scale up এটা কাৰ্বন ডটৰ কথা মই ক'লোঁ যে কাৰ্বন সিগমাইলকে বিচাৰিবে তেওঁলোকৰ ডিমাণ্ড আছে এতিয়া এই নেনোডাইমণ্ড ইমান আমাৰ ইণ্ডিয়াত কোনে কিনিব এটা বস্তু আপোনালোকে স্কেল আপ বা ইকনমিক ক'বলৈ গ'লে বায়াৰ লাগিব if there is no buyer what is the profit of মই মোৰ নিজৰ কথাই কোৱা নিচিনা হৈছে কথাটো হ'ল কি আজি পৰা 10 বছৰ পাছত খুব বেছি ডিমাণ্ড হৈ যায় it's a futuristic technology nanodiamonds from coal and from aerosol is a futuristic technology it's a futuristic আৰু সেইখিনি হোৱালৈকে এই nanodiamondখিনি আমি ৰিচাৰ্চ কৰিব কাৰণে ক'ৰবাত কিনিছোঁ US ৰ পৰা so সেই যিখিনি ইম্পৰ্ট হৈ আছে that will stop সিগমা ইণ্ডিকেটৰ ইয়াতে প্ৰডিউচ কৰিবলৈ ক'লে ইণ্ডিয়াত চ' সেই দুটা গতিকে কমাৰ্চিয়েল কথাটো প্ৰশ্নটো আমি ভবাৰ আগতে কিন্তু ইম্পৰ্টেণ্ট হ'ল বায়াৰ দেট ইজ মাৰ্কেট হোৱাট ইজ দ্য ডিমাণ্ড অফ মাৰ্কেট সেই বস্তুটো মষ্ট ইম্পৰ্টেণ্ট যদি মাৰ্কেট এনালাইচিছ নহয় তেতিয়া সেইটো আমি যাৰ কমাৰ্চিয়েল যাব নোৱাৰোঁ কিন্তু I can strongly say that even if somebody is interested to scale up, if you are interested to be of a startup, I told you that it can be scaled up very easily with very low cost. Even you don't need the big equipments which is required from China or other countries. In India, ठीक है sir?
Thank you so much, sir.
ধন্যবাদ থাকিল সকলোলৈ আমি আমাৰ শ্ৰদ্ধাৰ আমন্ত্ৰিত অতিথি ডক্টৰ বিনয় কুমাৰ শইকীয়া ছাৰক ক্ষমা কৰিব
নমস্কাৰ ছাৰ once again I just wish to congratulate you আচলতে ছাৰৰ কথাবোৰ আগৰ পৰা জানোৱে আমি জানো যে আমাৰ সালফাৰ কন্টেন্ট থকাৰ কাৰণে আমাৰ কোলৰ প্ৰাইচ কম অসমৰ কোল বিক্ৰী নহয় বাহিৰ বেলেগ আন সকলো ঠাইৰে ভাৰতবৰ্ষৰ কোলবিলাক মানে পাৱাৰ প্লেণ্টত ইউজ হয় that means we are in the witness of the coal of this region and you have made turned this weakness of the region to strength. That's why this is you are in front of us today with your prestigious Ratnagar Award. So I once again wish to congratulate you. So more just because scientist policy karne ami contribute koru amar government amar coal ami mane normal hokobwe jano je amar coal jiman ase jikhini resource apuni jeneke dekhuale etia ekhini misuse jothesta hoise bibhinno dhoroner mane karon ba bibhinno prokriyare to he misuse kini keneke etia apuni government mane kobo je misuse no koribo ba amar scientist community pa ami keneke mane he podokkhepto lwa jabo je ekhini as a resource ami in future or karone ami use koribo lage mane college na kothabur bad dilu কিন্তু it is a resource now you have invented it সেই কাৰণে আপুনি কি পদক্ষেপ লৈছে বা ভৱিষ্যতে ল'ব জাষ্ট সেইটো জানিব খুজিছো
বহুত টান কুৱেশ্যন মানে কি মই কৈছোঁ কথাটো যে হয় আপুনি ঠিকেই কৈছে যে ডেফিনেটলি সাইণ্টিষ্ট or ৰিচাৰ্চাৰ or প্ৰফেচৰ শুড এডভাইচ কিন্তু কথাটো হ'ল কি যে মই অকণমান আগতে ক'লোঁ যে we have to think for the future. A scientist or a researcher should think for the future, not for the current, not only for the current things. এতিয়া সেইটো কথাটো আছে কিন্তু 2 নম্বৰটো হ'ল যেটো মই ক'লোঁ যে এই ৰিসোৰ্সখিনিক মই ডেফিনেটলি আমি গভৰ্ণমেণ্টক এইটো পলিচি মেকিং বা পলিচি ডিসিশন মেকিং যদি তেনেকুৱা কিবা অনুষ্ঠান বা তেনেকুৱা কিবা বিচাৰে ডেফিনেটলি উই কেন সাজেষ্ট ইভেন মই দুবাৰমান মই চিফ মিনিষ্টাৰক লগ পাইছিলোঁ মই তেতিয়া অকণমান কৈছিলোঁ যে দিজ আৰ ভেৰি এছেঞ্চিয়েল ইউনিক মই এইটো কৈছিলোঁ ইউনিক ইন টাৰ্মছ অফ ধৰক মই যিটো ক'লোঁ আই শুড নট বিকজ এটা প্ৰজেক্ট মোৰ চলি আছে আমাৰ কোল টু গ্ৰাফিন এতিয়া কাৰ্বন ডটটো হ'ল ভেৰি হাই ভেলু ল' এমাউণ্ট টেকন'লজি আমাক মানে 1 ml বা 2 ml বা 5 ml কাৰ্বন কণ্ট্ৰাক্টতহে লাগে কিবা এটা বেছিক ৰিচাৰ্চ বা লেব স্কেল ৰিচাৰ্চ কৰিব কিন্তু গ্ৰাফিন ইজ এ ইণ্টাৰনেশ্যনেল ডিমাণ্ড কিন্তু এতিয়া আমি গ্ৰাফিনবিলাক আমাক কেজিটো নালাগে টনটো লাগে টু মেক চাম অফ দি মেটেৰিয়েলছ আজিকালি গ্ৰাফিন নথকাটো মেটেৰিয়েলছ তেনেকৈ ধৰক চবেই জানে যিখিনি সকলে জানে যে বিৰাট দৰকাৰী এতিয়া যেতিয়া সেই কাৰ্বন কণ্ট্ৰাক্টত কাম কৰি আছিলোঁ তেতিয়া দিল্লীত কোনোবা এজন প্ৰফেচাৰ মই এইটো নাজানো মোক এটা ফাণ্ডিং এজেঞ্চিয়ে ফোন কৰি ক'লে যে সেই প্ৰফেচাৰজনে মিটিং এখনত কৈছে যে দিছ নট ইজ কোল্ড আৰ সুইটেবল ফৰ মেকিং গ্ৰাফিন So sir, please give a project. মই খুজিলো নাই মোক ফোন কৰি ক'লে যে প্লিজ গিভ এ প্ৰজেক্ট হাউ টু কনভাৰ্ট দিছ কোল ইনটু গ্ৰাফিন আৰু কৈছে যে নিজতেহে কৰি আছে তেতিয়া ইমিডিয়েটলি এটা প্ৰজেক্ট লিখিলোঁ প্ৰায় 2 কোটি টকা গ্ৰাণ্ট পালোঁ এতিয়া যদি সেই প্ৰজেক্টটো কাইলৈ ছাকচেছফুল হয় ইফ আই কেন মেক এটলিষ্ট 25% ইল্ড যদি 1 কেজি কোলৰ পৰা আমি 250 গ্ৰামৰ যদি গ্ৰাফিন বনাব পাৰোঁ then we can definitely say to the government or the policy decision. Definitely we cover. কিন্তু কাৰ্বন কণ্ট্ৰাক্টৰ ক্ষেত্ৰত কি হয় এইটো যে মই ক'লোঁ যে মাৰ্কেটটো ইজ এ ইণ্টাৰনেশ্যনেল ডিমাণ্ড টু ছাবষ্টিটিউট দ্য দিছ এণ্ড আনাডাৰ থিং যিটো মই ক'লোঁ যে চেল ডিটেকশ্যনত যদি সেইটো যদি ইউজ কৰিব পাৰে সেইখিনি মই অকলেতো কৰিব কেতিয়াও নোৱাৰোঁ সেইখিনি যদি collaboratively কৰা হয় তেতিয়া সেই ডিমাণ্ডটো আহিব আৰু যদি এইখিনি হৈ যায় definitely we can suggest. Before suggesting, we need the evidence, we need the report data. Without data, যদি আমি কওঁ সেইটো এটা বস্তুটো report কোৱা নিচিনা হ'ব কিন্তু I am very happy that you are rightly mentioned that yes, we have to suggest the government or the policymakers how important are the resources of this region. So these two things are going on and definitely মই ভাবোঁ যে যদি এইখিনি আমি আগবাঢ়ি লৈ যাব পাৰোঁ definitely we suggest particularly coal to graphene project এইটো যদি হৈ যায় because graphene is a as a diverse applications supercapacitor batteries all these things and I also welcome the faculties to visit our institute. We have a prototype making facility of battery lithium-ion battery and supercapacitor by using coal powder. সেইখিনি কোল পাউডাৰ আমি ছালফাৰ থাকিবলৈ দিছোঁ কিন্তু দেই কোনোবা এজনে সুধিছিলে কথা ছালফাৰখিনি কিন্তু সেই বেটেৰীটো কাম কৰি দিয়ে আমি যে ভাবি আছিলোঁ মই ক'লোঁ ছালফাৰ ৰিমুভ নকৰোঁ এতিয়া নকৰাৰ কাৰণে সেই ছালফাৰটো বিকজ ছালফাৰ ইজ এ এছেঞ্চিয়েল কম্পনেণ্ট অফ বেটেৰী ইট বুষ্ট দ্য পাৱাৰ অফ এ বেটেৰী গতিকে সেই ছালফাৰখিনি ইম্পৰ্টেণ্ট কৰিলে চ' এইখিনি যদি হয় ডেফিনেটলি উই কেন ছাজেষ্ট অৰ উই কেন এডভাইচ টু পিপল গুড ছাজেষ্ট গুড কুৱেশ্যন থেংক ইউ
আমাৰ শ্ৰদ্ধাৰ শিক্ষাগুৰুসকল গৱেষক গৱেষিকাসকল আৰু ছাত্ৰ ছাত্ৰীসকলক মত বিনিময় অনুষ্ঠানটিত ভাগ লোৱাৰ বাবে ধন্যবাদ থাকিল আমাৰ শ্ৰদ্ধাৰ আমন্ত্ৰিত অতিথি ডক্টৰ বিনয় কুমাৰ শইকীয়া ছাৰক আমি আন্তৰিক ধন্যবাদ জনাইছোঁ অসমীয়াৰ এজন সুযোগ্য সন্তান হিচাপে আপোনাৰ কৰ্মৰাজিয়ে ইতিমধ্যে অসমৰ নাম উজ্বলাই গৈছে আমাৰ শুভকামনা থাকিল আপোনাৰ প্ৰত্যেকটো ভৱিষ্যত পৰিকল্পনালৈ ইমানতে আজিৰ এই মত বিনিময় অনুষ্ঠানটিৰ সামৰণি মাৰিছোঁ আপোনাক পুনৰবাৰ ধন্যবাদ জনাইছোঁ আৰু পৰৱৰ্তী অনুষ্ঠান মই আজিৰ অনুষ্ঠানটিৰ ঘোষিকা ৰাতামালী বাইদেউলৈ হস্তান্তৰ কৰিছোঁ ধন্যবাদ
So thank you. Particularly I must talk to thank I must thank the organizing committee. I mean the most particularly Korban Michael বহুত কথা বতৰা কেতিয়া ডেট এইবিলাক ঠিক ঠাক কৰোঁতে এণ্ড প্ৰথমে কেঞ্চেল হৈছিলে কিন্তু মানে কি মই মোৰ কাৰণে কিবা এটা পাৰ্চনেল ৰিলেশ্যন প্ৰেজেণ্ট কৰিছিলোঁ কিন্তু তাৰপিছত মই নিজেই কৰোঁ দেই যে মই যাবলৈ ইচ্ছা কৰোঁ চ' থেংক ইউ ফৰ অল দি হস্পিটেলিটি এণ্ড দি affection and the respect shown to this event. Thank you. Thank you very much.
Thank you, sir. Thank you, Bidut, for nicely moderating the session. Now for the recreation of the audiences, and I would like to request Mr. Gaurisankar Gogoi and Mr. Parthasarthi Gogoi, our fourth semester student of Department of Applied Geology, to play the musical melodies.
উপস্থিত সকলোকে শ্ৰদ্ধা জনাইছোঁ আমাৰ আগত পৰিৱেশন কৰিবলৈ লৈছোঁ এটি ভূপেন্দ্ৰ সংগীত আশা কৰোঁ সকলোৱে ভাল পাব
you, Partho. Now we have come to the end of the program. May I now request our head of the department, Dr. Digonto Bhuiya sir, to propose the vote of thanks.
Good evening. It's a great pleasure for us to thanks all the people here. Mainly, at first I would like to thank Honorable Vice Chancellor Professor L.K. Nath sir and Register Professor Jiten Hazarika sir for sparing their valuable time by gracing this event as chief guest and guest of honor in spite of their busy schedule. I also like to thank all other administrative officers of Jubilee University for extending all kind of support to organize this event. Then our sincere thanks goes to Honorable Union Minister of State for External Affairs and Education, Dr. Rajkumar Ranjan Singh, to inspire us with his gracious presence as the special chief guest. The main attraction of this event is Dr. Binoy Kumar Saikia. I would like to thank him for accepting our invitation to deliver the 4th Golden Jubilee Lecture of Department of Applied Geology. Thank you very much, Dr. Saikia. Then I also like to thank Dr. Manoj Kumar Phukon, guest of honor of NIST, to be here with us and grace the occasion. Next, I'd like to thank all the deans of faculties and faculty members of various departments of Jubilee University, and research scholars and students for their presence and making this event a successful one. I also like to thank all the media persons from various print and electronic media for covering this event. Last but not the least, my sincere thanks to our departmental colleagues, research scholars, students, and staff for supporting us in all that way to make this event successful. Thank you. Thank you.
Thank you, sir. Thank you, one and all present here. The program is formally ended here.